So let's now talk about the Milky Way, and you'll see very shortly how Cepheids were crucial to understanding the Milky Way. It was Galileo in the early 1600s who built the first telescope for astronomical use and found that the Milky Way was made of uncounted numbers of very faint stars. So this stream of milky light that we see in the night sky is really the light from millions upon millions of stars. The first person to try and measure the size of the Milky Way and map it out was a British astronomer by the name of William Herschel. And the way he tried to map out the galaxy was just by counting the number of stars in every direction. And he figured if there were more stars in a given direction, then the galaxy was bigger in that direction. And that would work if there's nothing to block the starlight. This is sort of the map of the galaxy he got. It's very different from what we would see today, but there are a couple of important things. One, notice the sun is not at the center. Now here it's close to the center, but it's not exactly at the center. We'll find out that with our modern maps, the sun is pretty far away from the center. And second, notice that the galaxy, although it looks sort of like an amoeba here, the galaxy is shorter than it is wide. The reason that William Herschel didn't get the proper size of the Milky Way, or one of the reasons that his method didn't work, is because he did not know that there was dust. And as we talked about under star formation, dust blocks and dims starlight. So here's a picture of the entire sky pieced together by an amateur astronomer who traveled to both the northern and southern hemispheres several times, took several pictures and stitched them together. The center of the Milky Way, which is in Sagittarius, is in the center of this picture, and then the rest of the Milky Way is spread out so that what we will call the disk of the Milky Way is left and right here. All those dark splotches you see along the center is dust that is blocking background light. A few other objects of interest. There are two companion galaxies to the Milky Way, located here. The Andromeda Galaxy, the nearest large galaxy to the Milky Way, is over here. And the constellation Orion and the Orion Nebula is on the right. It's distorted because of the way this picture is taken, but you can see his belt, you can see the star Sirius, and you can see the Orion Nebula. So back to our history of the Milky Way. It was in 1920 that an astronomer named Harlow Shapley, he was a Harvard astronomer, he noticed that globular clusters, these really old dense star clusters that we've talked about, they're not spread evenly throughout the sky. Open clusters, they're in the Milky Way, but they're pretty much equal numbers in every direction along the Milky Way. But globular clusters, there are a lot more in the direction of Sagittarius and Scorpius than there are in other directions. And so Harlow Shapley began to think, suppose that the globular clusters of the Milky Way are centered around the center of the galaxy, that they're sort of a swarm orbiting around the center of our galaxy. If we are not in the center, then we would expect the globulars to be in a higher concentration in the direction of the center of the Milky Way, and so that means that the center of the Milky Way must be in the direction of the constellations Sagittarius and Scorpius. Not only that, but he found RR Lyrae stars, these variable stars that Henrietta Leavitt had also worked on. Shapley found these in globular clusters, and so he was able to calculate distances to globular clusters, and sure enough, he found that most of them were not only in the direction of Scorpius and Sagittarius, but they tended to cluster around what we now call the center of the galaxy. So I'm going to skip through a lot of the details on how we can figure out the shape of the galaxy, because it's a lot like trying to sort out the shape of a forest from the trees, especially if you're tied to one tree and you can't move around. Through many different pieces of information, using Doppler shifts, using all the parts of the electromagnetic spectrum, we've been able to map out our Milky Way galaxy. And here's a rough picture of what the Milky Way looks like. So from above, the Milky Way looks sort of like this. It's a spiral galaxy with these spiral arms. In the spiral arm, new stars are being formed, and most of the dust is in the spiral arms. The sun is located about 2/3 of the way out, and you see that we are in between two spiral arms. Now, if we look at the Milky Way from the side, it's a disc shape. It's sort of a pancake shape or a frisbee shape, and we are inside that disc. We see the thin disk of the Milky Way stretching out to either side, and then it's a little puffier in the center. The center of the galaxy is about 8,000 parsecs, that's 26,000 light years away, in the direction of Sagittarius. This galactic center, we have to study it at wavelengths other than optical light because there is so much dust in the way that no optical light from the center of our galaxy gets to us. So we study it with X-rays, we study it with infrared light, and we study it with radio waves because these can penetrate the dust. The center of the galaxy in radio looks sort of like the picture on the left. The big streak is the disk of the Milky Way, and you notice there are several sources that here have been giving names like threads and arcs and other stuff. It's the shape of gas that's colliding near the center of our galaxy. And then you see a couple of things that look like circles. Those are supernova remnants. If we take the picture on the left and zoom in on this thing called Sagittarius A, which is the brightest radio source in Sagittarius, we find that there's a cluster of stars there, and that's what's shown on the right, both with adaptive optics and without. And you see that when we turn the adaptive optics on, we can see a lot more stars there. And here we find a lot of stars orbiting some unknown source, some source that's not visible in radio or infrared, and that's what we think is the black hole at the center of our galaxy. That little puffy part near the center of the galaxy that we can see from the side is called the galactic bulge. And the bulge is just a conglomeration of very old stars. It surrounds the galactic center, and it's about 5,000 light years in radius. So it's big, but given that it's 26,000 light years away, we're well outside it here at the sun. The disk is this frisbee shape or pancake shape wheel of stars that orbits around the galactic center. And the thickness of this disk it's relatively skinny. I mean, for stars like the sun, it's 1,600 light years thick, which sounds pretty thick, but remember we are 26,000 light years away. So it is really very flat, like a pancake. Now there's no sharp edge to the disk. It sort of peters out at its outer region. And also notice that near the center, near the galactic center, there's this slanted yellow thing on the artist rendition. This is the bar of the galaxy. So our galaxy has both spiral arms and a bar, so we will call the Milky Way a barred spiral galaxy. And in the next mini lecture, when we look at nearby galaxies, we'll see that a lot of spirals do have bars, although not all of them do. The sun orbits the Milky Way in almost a perfect circle, and at our distance it takes about 250 million years to go around the galaxy. So over its 4 billion year lifetime, the sun has only completed about 16 complete orbits, or basically the sun is 16 galactic years old. The sun's speed is about 220 kilometers per second, that's 50,000 miles per hour, and we can measure that using the Doppler shift in nearby galaxies to see how fast we are moving. People always wonder, where do the spiral arms come from? It's really a fairly complicated interaction of gravity, stars, dust, and gas. But basically, the gas in the disk orbits around just like the sun does. And if you have gas that's orbiting in a disk, it tends to pile up. And if you work through all the physics equations, the gas will tend to form spiral arms. Where the gas is piling up, it becomes dense enough for gravity to begin to shrink it down, and it can form new stars. And remember, when we form stars, we form all masses of stars, the faint, low mass reddish and yellow stars that live for a long time but aren't very bright, and the bright blue massive stars that only live for a few million years before they explode as supernovae. And so in the spiral arms, a lot of stars form. The bright ones are the easiest one to see, so they're going to be blue. But before they can move away from this spiral where they form, they end their lives and die and blow up. The spiral arms, when we look at spiral galaxies, are very young stars that have just recently formed and haven't moved very far since they formed and are going to die and blow up before they move out of the pattern. The rest of the galaxy, we can't see it in pictures like this, but there is a full circle of stars here, of stars like the sun that can live for billions upon billions of years, but they're not very bright, so they're much harder to see from far away. The last part of our galaxy is called the halo. The halo is a more or less spherical system of stars and globular clusters that surrounds and permeates the entire Milky Way. You can think of us as a frisbee embedded in a swarm of stars and clusters. All the stars in the halo of the galaxy are ancient, among the oldest stars that we know of, between 11 and 13 billion years old. And most globular clusters belong to the halo of the galaxy. So let's summarize our current view of the Milky Way. From above, the Milky Way probably looks something like this. This is a picture of another galaxy, but we probably look close to this. A circle of stars with spiral arms and dust where new stars are being formed, and a small bar toward the center, centered on the galactic center. The Milky Way looks like this from the side. This is an actual picture in the infrared, and you can still see a little bit of the dust, but it's very flat, very skinny, and toward the center we have this little bulge. So the parts of the galaxy I want you to be able to know and to identify are the galactic center. Know that it's about 8,000 parsecs away, or 26,000 light years. It has a supermassive black hole there. The galactic bulge that surrounds the center of the galaxy is made of mostly old stars. The galactic disk, that's this pancake-shaped wheel of stars that orbits around the center of the galaxy, and the sun and all the spiral arms and stars of all ages, from the youngest stars in our galaxy to some fairly old ones, are part of this galactic disk. Finally, there's this tenuous galactic halo that's a spherical distribution of ancient stars and globular clusters that surrounds and permeates the Milky Way galaxy. So this completes our introduction to the Milky Way. The Milky Way was mapped out by finding Cepheid variable stars and RR-Lyrae variable stars that allows us to determine distances, because these distances to the center of the galaxy and other parts of the galaxy are so big you have no hope of detecting parallaxes. We found that the galaxy has different parts, and each part has its own unique characteristics. And what we will soon find is that our Milky Way galaxy is a fairly typical galaxy in the universe. And so in later mini-lectures we will see other galaxies, see how they interact with each other, and then we'll talk a little bit about this mysterious dark matter. You can now go on and complete the response to this mini-lecture.